Welcome to video of problem 2, Advent of Code 2021. Just make a note, there is an intended audience for this video, but it is on the public internet. So just make it clear that the intended audience is a group of students who are programmers still learning Python as a first language. So that explains some of the level at which it's set. Okay, so day 2. You can pause and read the detail if you like. I'll just sort of summarize. So we're trying to pilot a submarine, and we have a series of commands that look like this: forward 5, down 5, forward 8, up 3, down 8, forward 2, right? So of course the forward ones move you forward. So 5, 8, and 2 makes 15. So that means 15 units forward. Down, up, and down, they're sort of opposite to each other. So down would mean that you go deeper 5 units, and up you go deeper -3 units, if you like. So you've got to track the position and the depth, right? Your horizontal position and depth both start at 0, and you just got to track them, and you'll get a final position and depth, and then you just arbitrarily multiply those together to get the numerical answer for this puzzle. Okay, I've done this. I actually recorded a video earlier where I was doing it without having prepared anything, thinking that would be interesting, and it was, but I got really stuck in, well, I just felt that problem 2 was quite complicated and it would have just gone on forever and ever. So I'm re-recording with preparation. Okay, I'm going to do the Python one first because it's actually quite complicated in Clojure. Not super complicated for someone who's experienced, but if you're not experienced, then yeah. So we might as well have a look at it in Python first, and I haven't prepared this. Okay, so I've got the test data and the real data here. I'm just commenting out the real data because it's such a long line that it stuffs up the syntax highlighting. So anyway, all right, so what we're going to do is we need to get every line of this, right? The \n is a new line character. We need to split this into lines. So I'll say for line in text, that's the argument that's passed in, dot split on new line. So that should be enough there. And now we've got to split it on space. So we've got to get the forward and the 2 separate from each other. So I'll say, let's say instruction and value equals line dot split on space. So I can just say split, and the value, we really want it to be an integer, not a string. So I'm going to change that. And now it's just a case of tracking the position and depth, right? So them to 0 and 0 to begin with. Right, now it just now depends what the instruction is. If the instruction is forward, then we're going to add to our position. So if the instruction is down, then we're going to add to the depth. If the instruction is up, then we're going to subtract from the depth. When we get to the end of the loop, we should have a position and a depth, and we just return the product. Okay, so let's run this on our test data. So print P02A on test 02. And I have to run this whole file. I'm going to save it first. Okay, so there's an error from last time. So that is and I've got an exit here. We don't really want that. Okay, so let's not do that, and let's just comment those assertions out. Right, that should be okay. So we've got 120. Now, it's interesting because we're supposed to get 150. So we'd better see what we're getting. Right, so we're getting an instruction and a value each time. So let's just print the instruction and the value each time and see how that goes. So forward 5, down 5, forward 8, up 3, down 8, forward 2. And I've got that in the background there. So, right, we are representing the instructions correctly. All right. And goes after, we'll print the position and the depth after we've processed each. So position 5, naught, forward 5, yep, down 5, looks good, forward 8, position 13, up 3. Yeah, it says 13, 0. Interesting, and then down 8, forward 2. So up 3 should not be taking the depth to 0. Okay, and that's because I've got depth minus equals depth. So that, all right, so just a simple error. Anyway, I'm glad that happened because you get to see how you do a bit of debugging, right? Just to see what's going on. Right, I'll get rid of those now. Right, so 150, yep. And if I changed it to data, then I need to uncomment this. Right, so 1692075, and that's the answer that I've got here. Okay, now that was quick, all right. So I realise for the intended audience of this video that it's kind of your current challenge to be able to do a problem like this quickly in Python. But there's a real, there's a real similarity to what we've done in the past where we are setting some initial variables, going through a loop and changing those variables, right? It's only the details that are different. Now, I'm going to do this in Clojure now, and it's going to seem much more complicated. And that's kind of unfortunate. So let's just talk about that to begin with. I claim that Clojure is a much more elegant and in very many ways better language than Python is. So why would I want to use a language that takes a problem like this and makes it seem much more complicated? Well, the thing is, you just have to kind of approach the problem differently. So in Clojure, you don't go changing variables. Made that point before. So you don't sort of set them up here and then add to them here, right? What you do is you calculate new values. But because we're keeping track of two values here, then we need to keep track of them as like a combined value, right? So we're going to keep track of them in what's called a map. Python would call it a dictionary. Okay. In Python, actually, I'm going to just realize it'd be a good idea to demonstrate this now. So instead of having position and depth as separate, I'm going to call it state, right? What's the state? Because I keep updating the state. So say the position is 0 and the depth is 0. Right now, that just looks like a more complicated thing than what we had before, but it looks equivalent. And yeah, it kind of is. And now, instead of updating a the position variable. We don't have a position variable, so I just have to access the state and look up the position within the state, and I can add the value to that. And oops. Okay, so this is now going to, and then now instead of changing this to state pos times state dep, I'm going to change it to something else, right? I'm going to take the that's unfortunate. No, all right, I will do this. Okay, state pos times state dep, and so I should be able to run this and get the same answer as before. No data, same old problem. I'll change this to just test. And yep, so same answer as before with the test data, 150. Okay, so this is a bit more complicated than before, but in a way it's a bit simpler because we're keeping track of one value throughout instead of two. And so I want you to imagine a problem where you had to literally keep track of 10 things. Well, if you put them all into a map like this or all into a dictionary, then conceptually you're only keeping track of one thing. And so a lot of problems kind of reduce down to this same pattern. Set up your initial state and then calculate the new states based on it. Now, Python is still mutating this. We've got the one thing that we're changing, right? But in Clojure, you don't change things. You create, you calculate a new state. And there are some very, very significant advantages of that I won't go into now. Anyway, so it's a good thing that I've done this because it sort of eases us in, but there's still some very significant differences between the Python approach here and the Clojure approach. So the Python approach is very much a case of create something, go through a loop, and keep updating it. Well, now if I show you what I'm going to do in Clojure, right, then you think of it as a flow of information. So we're going to start with turning the plain text into these separate instructions, forward 5, down 5, forward 8, and so on. So this is a list of text instructions, and then we're going to transform that into a list of more structured instructions, so each one of these is a map that has an instruction and a value. So we're going to turn each of these into this before we go forward. So we've got the instruction is forward, and the value is 5. The instruction is down, the value is 5. The instruction is forward, the value is 8, and so on. Remember that commas are ignored by Clojure, so I'm using them like a dot, dot, dot. Right? And so then, when we've turned our instructions into something that's more computer-friendly rather than text, we're going to take this list of things and turn it into a single value. And that is going to look complex when we do the code. And then when we've got those, then I'm just going to pull out the 15 and the 10 and multiply them. Okay, so I've got a little doc string here, okay? Process a sequence of instructions forward 14, down 13, and so on. Produce a single number that is the horizontal position times the depth, both of which start at 0. All right, so I'm going to start this by defining, or at least I'm going to presume that I'm going to define some local variables, or local values, I should say. There aren't really variables in Clojure as such. And so I'm going to start by turning the text into lines, or getting a sequence of lines. And then I'm going to map a function that I'll call parse over that. And so that will turn forward 5 into instruction forward value 5, right? And then I'm going to reduce this sequence of instructions into a single value using a function called reduce. So this is where, if you're not familiar with it, then it's going to seem complicated, right? But I promise you it's impossible to solve like really significant problems, whether it's advent of code or anything else, like practical real world problems. It's practically impossible to solve such problems without techniques like this. Okay, so might seem a bit much if you're not used to it, but it's fine when you are used to it. Okay, so reduce. We need a function that reduces each of these as it goes along. And I'm going to call that function f, and I need a starting value, and I'll explain more later, but I'm calling that accumulator 0. And I'm going to leave it there for now, and we'll run the code once we've got something going on. Okay, so the question is, well, I've got 3 things here highlighted because the code doesn't know what they are. So what's parse, what's f, and what's accumulator 0? Right, well, let's get into it. So parse is a function that takes a string like forward 5, and we need to, okay, I'm going to pull out two values a and b, which is simply the to separate it into words, right? And then once I've got that, then I'm going to create a map that has instruction as the keyword of A and the value being a parse long of B, right? That's because B would be like, this forward 5 is a string, and we don't want that. We want it to be numerical. So that's what parse long does. It's like int in Python. Long is a computing term for like a long integer, so an integer that can be really big. And now I haven't explained keywords. So in Python, when I put something into a dictionary, I was using, all right, so a dictionary has keys and values, and I was using strings for the keys because Python doesn't have anything better than strings to use for the keys, and that's really unfortunate. Clojure uses maps all the time, and so it has these things called keywords that are good for using as the key in a map. So how is this different from a string? Well, a string is like literally a collection of characters in order. And you can ask for like, what's the third character? Whereas a keyword is like a token. It's like a stamp, right? And it basically just is what it is. And you cannot take a keyword and say, can you please give me the third character? You can turn it into a string if you want to and then ask for the third character, but the keyword is just a value that has a nice representation. We put the colon and then spell it however we like. And the point is, take a look at this, right? This is going to be true because those two strings are equal, but they're not the same thing, right? They're not the same position in memory. There are two copies of the string, but they happen to be equal, and Clojure has to check each letter against, it has to check the first, then the second, then the third, then the fourth. That's inefficient. Whereas this, they're literally the same thing, and so the comparison is instant, right? So it's more efficient. So that's really important. Okay, anyway, so keywords, they're used whenever you just need a token. And I need a token to represent the instruction and a token to represent the concept of value. Okay, so what I might do is hide this one so we can actually run this code, and I'll run it. So P02A, given the input, and I want P02 test. Right, there we go. Right, so I've I've been able to read the lines of text and then for each one turn it into like a real instruction. Okay, so what now? Well, now I'm going to do this reducing, right? And okay, so start with the accumulator. No, I'll start with a little introduction to what reduce means. So reduce, I showed this before, reduce plus 6, 3, 2, 8 is give you the sum of these. Basically, it's starting with the empty sum, which is 0, right? And then adding 6, and then adding 3, and then adding 2, and then adding 8. And if you needed to start with something else, then you can. Okay, then you can. I could do times instead, right? Or I could do my own function that's a bit more funky, and it takes now the function that reduce uses takes an accumulator and a value. It's called an accumulator because you're just accumulating the value as you go. And I'm going to make this interesting. Like I'm going to say, take my accumulator, and I'm going to multiply the accumulator by 2, and then add 3. And we get 69 as the answer. And if I change reduce to reductions, then it gives me all of the intermediate values. So the accumulator starts at 6, and then the rule is double and add 3. So if you double and add 3, then you get 15. And then if you take, sorry, I need to add the x. Oops, I haven't used the x value at all. That's silly of me. Okay, so the reduced value here will be 72. So can I just remind you that we're taking a list of things here and reducing it to a single value, right? That's why it's called reduce. Now, so the accumulator starts at 6. Then we double it and add 3, which gives us 15. Then we double 15 and add 2, which gives us this 32. And then we double 32 and add 8, and that gives us 72. Right? So reduce gives you the final value. Reduction shows you the working, if you like. So what we're doing here, right, this is now going to get a bit complicated, unfortunately, but our accumulator 0, so our initial accumulator, is going to be a map that contains the x position of 0 and the depth of 0. So in Python I called it pos and depth, so I'll do the same thing here, right? The position is 0 and the depth is 0. That's my initial values, right? And then I have the function that updates this, right? And so this is a function that takes an accumulator and a value x. And what I'm going to do is I'm going to destructure the x, right? Now, x is a very general thing. I think I'll call this instruction because that's what it is, because it takes an instruction each time. Now, the instruction has keys in it that are like inst and val. So I want to pull them out so I can use them. And then what I want to do is now what I need to do depends on the case, right? So it depends on the instruction. And so you get this here, if, elif, right? One of the worst things about Python is that it's got no way of doing a multi-way if, right? Every other language has, usually called case or switch, right? Python is just if, elif. Ridiculous. Anyway, so in Clojure, we say case, right, inst, right? Now that's either going to be forward or down or up, right? So that's like my if inst is forward, otherwise if inst is down, do this, otherwise if inst is up, do this. But it's not do this, right? In Clojure, it's not do this, it's calculate this. And so what we're doing here is calculating a replacement accumulator. So what we can do is we can update, you haven't seen this function before, we can update the accumulator, and we want to take now if it's forward, we want to take the position and we want to add the value, right? VAL, val, right? And if we're moving down, then we want to update the accumulator, but this is the depth, and we add the value. And up, then we update the accumulator and the depth, and we subtract the value. Okay, so here's documentation for update, right? Updates a value in an associative structure. So an associative structure is a map where K is a key and F is a function that will take the old value and any supplied arguments and return the new value, returns a new structure. If the key does not exist, it's blah, blah, blah. So if we just sort of look at this example, def P for person, we've got name is James and age is 26. And if we update P, age increment, then the age becomes 27. Now it has not destroyed the original value, right? So that's why it says updates in quotes, because it's not updating anything, it's creating a new map. And if you want to update P, age plus 10, then James is now 36. And if you want to update P, age minus 10, then 16. So this is the bit, right? So in Python, you got if, elif, right? And then you are updating in place, whereas here, instead of if, elif, you've got a much more elegant case, right? And then this is saying, well, what value comes from this? Well, an updated accumulator comes from this. And that's exactly how the reduce function works, is by you keep calculating new accumulators. And whatever you end up with at the end is, well, that's what you get. So I can compile this now and run this, and you can see, having run all the instructions, we end up with a position of 15 and a depth of 10. Okay. So there's no for loop in this, right? Clojure doesn't have a conventional for loop because it doesn't have that normal computing approach of do this, now do this, now do this, now go back there, right? It doesn't do things, it calculates things. All right. So now we need to now get the 15 and the 10 out. Well, that's really easy. By the way, $1 just gives you the last value. If I ask for the values of $1, then it just gives me 15 and 10. So now that I've got that map, I can get the values out of it by just saying vals, right? So if I compile, and run, then I get 15 and 10. And take a look at this. If I want to multiply 15 and 10 and get 150. What if I've got 15 and 10 in a collection? Then that's an error, right? But what I can do is I can say apply this function to those values. And so I can do this, get the values out, and then apply multiplication to those values. And then when I run it, then I get 150. Okay, so that's very nice. So Problem 2, if I try it with problem 2 data, then I quickly get that answer. All right. You can generally expect Clojure to be about 10 times faster than Python. I may have just made that up, but I think it's fairly realistic. Okay, now problem 2b, we haven't read it yet. Now it's a bit of an awkward problem, right? If you want to pause it and read it, go for it. I'm just going to quickly explain it. We've now been told that the instructions are actually different, like forward and up, down and up don't mean quite what you expect them to mean. There's another value called aim, right, that also starts at 0. Now, down and up, they change your aim, right? It's never really explained to us what aim means here. And then the forward instructions, right? So down and up have nothing to do with your depth. The forward instruction, well, it does two things. It increases your horizontal position. Now that's what it did before. And it increases your depth by your aim multiplied by the value. So this makes no physical sense really. So it's a bit of a slightly disappointing problem. Not complaining, but you read it and it doesn't make much sense. Okay, there's instructions there which I've read and so on. And if you want to read it, then go for it. And once again, we're still calculating the final horizontal position by the final depth. Okay, but anyway, down and up affect the aim, and forward affects the horizontal position and the depth. That's what we really need to remember. But otherwise, this is much like everything else. And so problem 2b is going to have the same structure as problem 2a. And so what I'm going to do, I'm actually going to take this parse out. See, I put it in here thinking that it would only be necessary for this one function. But now I need to parse stuff in the other one as well. So I'm going to delete this and paste it out here and turn it into a function that anyone else can use. So I'll call it parse02 because a lot of problems are going to require some parsing. Okay, so that's, and I'll get rid of the that, right? And so that bit's fine, and just get rid of this and change this to parse02. Right, now I'm just going to reload the whole file and check this, still works good. All right, and now I'm going to copy all this, paste it down here, get rid of this nil. Okay, so the instructions do different things, right? So let's just look here first. We still need to do this, right? To take the input and split it into lines. We still need to parse it into instructions. We still need to do a reduction. It's just the details will be different. We still need to get the values and multiply them. Now, this line will change, but I'll explain that later. So the accumulator is now going to have 3 things in it, and the aim is 0. And the function, well, it's still, like this line doesn't change. We still have a function that takes an accumulator and an instruction. We still need to pull out the inst and the val of the instruction. And we still need to do case for forward, down, and up, right? But I'd like to point out that down and up are now the simple ones. So I'm going to move forward to the end. Oops. Okay, move forward to the end. So down and up, they actually now, down increases the aim and up decreases the aim, right? So down and up are now doing the right thing. Forward, it increases, it does 2 things, right? And so I've got a bit of a difficult situation here because this update can only handle changing one thing, right? It'd be nice to, so let's just see what we've got. We need to increase the horizontal position. Yep. And it'd be nice if we could say also, would you mind if we take the depth and add, and we need to, the aim multiplied by x. Now x is the value. And then to get the aim from the accumulator. Okay, that's what we would like. So if I can just read that out to you, we want to update the accumulator, take the position and add the value, take the depth and add the product of the value and the aim that's sitting in the accumulator. All right, we'd like this, but we can't do it. Okay, so what we can do, I'm going to keep that there so we can look at it, and then I'll delete it later. So rather than call it, we're not going to call update yet. We're calling this thread, and we're going to call update twice. We update the position and add the value, and we update the depth, and we add the product of the value and the aim that's in the accumulator. Now, something's missing here, right? The word after update everywhere else was accumulator, but I haven't mentioned that here. Well, what actually happens is that this macro is threading the accumulator through it. You've seen me use this thread macro before. I didn't bother explaining it. I just let you use your intuition that say, right, we take that and then we do this. Not do, but then we calculate this, then we calculate that, then we calculate that, then we calculate that, right? So what's happening here is this is taking the accumulator and popping it in that first position. And then when this line's done, it's popping that result into this first position here. And so that gives us a nice idiomatic way of updating more than one value, and that's very nice. So I'll get rid of this now. Okay, so this should almost certainly will almost work. What I'm going to do is I'm going to tag this and okay, file and now run this with the test. Okay, so what we got an answer of 9,000, which is neither here nor there. After our test data, we've got a position of 15, a depth of 60, and an aim of 10. Okay, and this tells us that we do have a position of 15 and a depth of 60, right? It's just that this doesn't tell us about the aim because, here we go. Oops. Okay, we do have an aim of 10 at the end. All right, so see how I could just put the word tag in there? That's something I created. It's not built into Clojure. It just means that you can see a value that's partway through your big calculation, and that's a nice thing to do. All right, so the thing is, we don't want the aim, right? And so I've just actually thought of another way of doing this. So I can before I take the values, I can dissociate the aim, as in that gets rid of it from the map. But I don't think this will work because the map needs to be in the first position, and this is called the thread last macro. This will put it in the last position. So this would have worked, like if I get rid of the aim and then take the values and then get the product, right? But anyway, nice in theory. There are ways I could force this to work, but I'm not going to. What I'm going to do, rather than vowels, I'm going to do something that looks a bit strange. And that's it. And this is going to work. or not. I need a, and when I run it, I should get 900, and I do. So what's going on here? Well, this is a function called Juxtapose. And what it does is it takes two functions, the position and the depth, right, and applies it to the one value. So I can give you a really simple value here, really simple example, sorry. I'm going to define f to be a function created by juxtapose, increase and decrease. And that's it. So, and now if I call f on the value 10, then I'm going to get 11 and 9. The 11 comes from increasing 10, and the 9 comes from decreasing 10. Okay. I'm going to put, just trying to think of what other things I can put in. Okay, I've now made it, and if I call f on 10 again, right, then I've got 11, 9, true, and 40. So basically, inc is making 11, dec is making 9, int question mark is making true because it's asking, is it an integer? And then this is an inline function, right, that takes a value and multiplies it by 4. So that's where I've got 40. So juxt is short for juxtapose, which means put things next to each other. It's a very cute name, right? It's applying all of these functions to the one value and then putting the results next to each other. It's really nice. Now I can put this inside there, right? Okay. And so what this is, Juxt creates a function, and now it's being called immediately. All right. Now you probably get a sense of why Clojure is called a functional programming language. All right. It really is about creating and using functions above everything else. And so what I'm doing here, all right, so the result of my reduction is a map that has pos, dep, and aim in it. And what I'm doing is I'm just pulling out the pos and the dep values, and they'll get a list. And then, right, so, and then I just apply multiplication. Okay, and so let's try this with the real data. Right, I'm just going to make sure I've got everything loaded. Okay, so I've got a really big value here, right, and I haven't submitted this to Advent of Code yet, but I'm very confident it's going to work. And that's the right answer. All right. So if I return to the Advent calendar, the picture looks a bit different from yesterday, and it'll keep evolving over time. The person who creates this is, right, look at about, someone called Eric Wastel. And he's done it for 5 or 6 years now, and there you go. All right, so I'm not going to do the second part in Python. I don't see any value in doing that, but yeah, just hope you learnt a thing or two about Clojure. And trust me, even though this looks complicated, it's something that you can appreciate and get the hang of it. And there's something that feels really good about just calculating new values based on old ones rather than continuing to mutate things, right? Mutating things is really a source of bugs that can be hard to find because you keep changing things but you never get to check, like, are they what you expect them to be? Okay, now that's exaggerating a bit, but yeah, from experience, it is the source of many bugs. Okay, see you in the next video if there is one.